Alright, students, so in this video we're going to be looking at how to use the cosine. So after watching this video you should be able to understand how the cosine rule relates the three sides of a triangle and one angle all together. You should be able to apply the cosine rule to calculate the length of a third side, or apply the cosine rule to calculate the size of any angle in a triangle given you know all three sides. Alright, so the sine rule is unhelpful in calculating any values in the triangle below because we don't know any opposite pairs. We know this side but not the opposite angle. We know this side but not the opposite angle. We know this angle but not the opposite side. In this other example, we know all the sides and no angles. So in these situations, using the sine rule is not going to be helpful, because with our sine rule we always need to know that opposite angle and side pair. So we are going to use a different sort of rule in these sorts of situations. So the cosine rule is different to the sine rule as it uses the included angle. So the included angle is the angle in between both of our known sides rather than opposite angles. So cosine rule uses included angles, sine rule uses opposite angles. Now the cosine rule relates all three sides of a triangle to one of its angles. And it states that little c is equal to a squared plus b squared minus 2ab cos big C. So cos of the angle opposite. Right, so big C is opposite little c, so it's the angle opposite that we're finding the cos value of, but this angle here, C, we know, and we also know A and B. That C angle is in between our known A and B values, and that known angle C is opposite the unknown side that we want to find. Alright, now with the cosine rule, the start of this formula should look a bit familiar. This a squared plus b squared business, that looks a lot like Pythagoras. So this part here is Pythagoras, which is useful for right angle triangles, and then this little part at the end is a bit of an adjustment. It's an adjustment that we include for non-right angled triangles. So altogether the cosine rule is c squared equals a squared plus b squared minus 2ab cos big C, the angle in between A and B. Now the cosine rule, as we've already discussed, is best used when we don't have those opposite angle and side known pairs. So we might know an angle or a side, but none that are opposite each other. That's when we use our cosine rule. Alright, so let's use this as an example. Calculate the value of x in the triangle below. Alright, so labeling, here's our angle big C. So our little c side must be opposite. A and B don't really matter. Right, they're just the two sides, either side of our included angle. So the cosine rule says that c squared equals a squared plus b squared minus 2ab cos C. Alright, then substituting values in, 7 squared plus 10 squared minus 2 times 7 times 10 cos 72 degrees. So that's 149 is 7 squared plus 10 squared minus 140 cos 72 degrees, and that's c squared. So to find c, we can do square root 149 minus 140 cos 72 degrees. Now we don't need the plus minus sign in front of our square root sign because that longest side has to be positive, right? We're talking about sides, we're talking about distances. We can only really consider positive values for c, or for x in this case. So it's worth it's not even worth putting the plus or minus sign in, because we know as a distance x has to be positive. Putting that into our calculator, we end up with a value of 10.28 centimeters. And that's the length of our side x. And that's all the cosine rule is. Substitute your values in, get your answer at the very end. All right, students, so in this example, we're going to find out the size of an angle, given the other sides. So C is always our angle, big C. Little c will be the side opposite. A and B are either side of our included angle here. Now, starting off with the cosine rule, what I'm actually going to do is rearrange this formula we've got here. I'm going to rearrange it and ideally get cos C on its own. So what I'm going to do first is subtract a squared and b squared from both sides. So c squared minus a squared minus b squared equals negative 2ab cos C. Now I don't really like this negative here, so I'm just going to divide everything by -1. So that'll be negative c squared plus a squared plus b squared equals 2ab cos C. I'm just going to rearrange that left-hand side. So the positive terms are first, a squared plus b squared minus c squared. I'm also going to divide both sides by 2ab. This part here in front of cos C. So divided by 2ab equals cos C. So now we've got a formula for our angle capital C. So I'm just going to substitute our values into this equation here to get our value for cos C. Cos C is going to equal a squared, which is 12.3 squared, plus 29.1 squared, minus 34.6 squared, all over 2 times 12.3, not 1.23, times 29.1, and so C is just going to be the inverse cos of that number, 12.3 squared plus 29.1 squared minus 34.6 squared, all over 2 times 12.3 times 29.1 and bracket, and as an angle that gives me 106.15 degrees for that obtuse angle, which according to our diagram here, and if the scale's right, looks like it's reasonable. Additionally, that's quite a large angle, 100 degrees, and it's definitely opposite the largest side, so it makes sense on that front as well. Now for the cosine rule, there is no ambiguous case. So whatever number we get with the cosine rule, that's definitely the right answer. Alright, so after watching this video, you should be able to understand how the cosine rule relates the three sides of a triangle and one of the angles. You should be able to apply the cosine rule to calculate the length of a third side, and also apply the cosine rule to calculate the sides of any angle in a triangle, like in that last example.